the equation is y equals, it's a fourth degree polynomial. So I already put down the p and the q values. Remember, the p comes from the constant, the q comes from the leading coefficient. So once you do p over q, you get plus or minus 1, and then plus or minus 1/2. Okay, so these are the 4 possible rational zeros. So based on the picture, it looks like it might be 1 and possibly negative 1/2. It looks like it's negative 1/2 right there. So let me just erase it so you can get a better view. So I'm thinking I'm going to try positive 1 and I'm going to try negative 1/2. I'm going to try those two first and see what I get. Notice how this is like 3, almost 4, and nothing in our list even comes close to that. That's because that's an irrational zero, and that, you can get irrational zeros, so, and that's, that's fine. So I'm going to start with 1. So 1, and so that gives me, I'll put the numbers here, 2, negative 9, 5, 3, negative 1. So bring down the 2, negative 7, negative 2. Okay, so it worked. Okay, it worked. I'm going to try 1/2. I'm sorry, negative 1/2, because it looks like it's a 0 based on the graph. It could be. So I'm going to try negative 1/2. So remember, use the reduced polynomial coefficients, which would be these right here, the ones from this line. These are ones that give you the reduced polynomial. And so 2, that would be negative 1, because 2 times negative 1/2 is negative 1. Combine, you get negative 8. Negative 8 times negative 1/2 is positive 4. This gives me 2. 2 times negative 1/2 is negative 1, so I get 0. So it worked. Okay, it was a 0. So now I have this left. So this is 2x squared minus 8x plus 2. And it doesn't factor. 2 times 2 is 4. There are no factors of 4 that add up to negative 8. Okay, so then when that fails, we go to our reliable quadratic formula. So that's going to be negative b Okay, so I went ahead and I calculated, after I simplified the quadratic formula, I got 2 plus or minus radical 3, and then I put in the 2 plus radical 3 in a calculator and 2 minus radical 3, and I got these two numbers. So you can see that it's the ones that I highlighted in blue over here. Here's a 0.268, and here's a 3.732. So those are your irrational zeros. So these two are your, rational that I got from the list up here, from the P over Q, and these two are the irrational. but all together they're all real numbers. Okay, and so see how it's 4 and our polynomial is degree 4. So all of that matches. Alright, for 86, you've got plus or minus 1, plus or minus 2 for p, because that's your constant, and then q, your leading coefficient over here is 1, so that's why it's plus or minus 1. So p over q would give you the p list, right, because q is plus or minus 1, so p over q is just basically looking at the p, list of p factors, so plus or minus 1 or 2. Now let's take a look at the graph. Based on the graph, I see that probably negative 2 is going to work, and possibly 1. I see a 1 right there. I see it crossing there. This one over here is going to be an irrational number, okay? Because it's almost, what is it? Almost 6. That's not on the list. And then a number between 0 and 1. It looks like. So let's start off with the ones that we're pretty sure are the zeros. So negative 2 and positive 1. They're on our p over q list. So negative 2. And so I'm just doing the synthetic division. Okay, so yep, it was a 0. Then I'll try the 1. And remember, we're using the reduced polynomial coefficients. So bring down the 1. Bring down the 1. Okay, so this quadratic right here is x squared minus 6x plus 1, and it does not factor. Okay, it's obvious that it does not factor. So we're going to use a quadratic formula. So x equals negative b, well, I'll put the 6, plus or minus the square root of b squared, so it's negative 6 squared, minus 4 times a times c, all over 2a. So we're going to simplify. Minus a negative 6 gives you 6, plus or minus 36 minus 4 over 2. 36 minus 4 is 32. And we know that 32 is 16 times 2. This is 16 times 2, so this is going to come out as a 4. And so this is going to be 6 plus or minus 4 radical 2 all over 2. I can factor a 2 from the numerator. So this is 2 times 3 plus or minus 2 radical 2 all over 2. So the 2's cancel because that's 1. So my zeros are, fit here. Oops, I ran out of room. So let me just move it to the left a little bit. So the zeros are negative 2, 1, and 3 plus or minus 2 radical 2. So I went ahead and punched in the 3 plus and minus 2 radical 2 on a calculator. So for the 3 minus 2 radical 2, I get 0.172, and it's dot dot dot, right? It goes forever. And for the 3 plus, I got 5.828, and of course it goes on forever. So yeah, that pretty much matches what we have on the picture here, right? The number I circled, that's about 5.8, and then the one that is right between the 0 and the 1 is about 0.172. So for 87, here are the p's and the q's. So I'm going to start off by taking the plus or minus 1 from p and putting it over each of the q factors. So 1 over 1 is 1. 1 over 2 is 1/2. Then I move on to the 3. 3 over 1 is 3. And 3 over 2 is 3/2. So there are 8 possible rational zeros for this polynomial. And notice the highest number is 3, and I see right here that the graph almost, it passes 8. So I know that I'm going to have irrational numbers, okay, for zeros. So let me erase that. Okay, so it looks like from the graph that it could possibly be, I was trying to see if we could zoom in, but it could be -1 that it crosses through and +1. I'll try and see if those work. So I'll try -1. Oops, change the color. -1. So -2, 17, -25, and -3. So -2, this gives you 2, 19, -19, -22, +22, -3, 3, and it worked. Good. I'm also going to try +1 because it looks like it might cross through +1 or maybe 3 halves. If it's not 1, it could be 3 halves, 1.5, right? I'm looking at this part right here. It's kind of blurry, but in your book you could probably have a better view. So it might be 3 halves. So let me try 3 halves. And we could, always change it to 1 and see what happens. So -2, 19, -22, -3. So bring down the -2. 3 halves times -2 is -3. Combine these two, you get 16. 3 halves times 16 is 2 goes into 16, 8, 24. And then you get here 24 minus 22, 2. 3 halves times 2, the 2's cancel and you're left with 3, and so it worked. Cool. So it was -1 and 3 halves. So this is a polynomial, and notice how they're all divisible by 2. So I'm going to go ahead and factor out a -2. So this would be x squared minus 8x minus 1. And again, this obviously does not factor. Okay, so I'm going to have to use a quadratic formula. So let me just set it up. So we have -b plus or minus the square root of b squared minus 4 times 8 times c all over 2a. So I get 8 plus or minus the square root of 64 plus 4, because a negative and then a negative over here, that's positive, all over 2. So that's 8 plus or minus square root of 68 over 2. So 68 is 4 times 17. So the 4 is going to come out as a square root of 2. As 2. And so you get 8 plus or minus 2 radical 17 all over 2. I can factor out a 2 from the numerator. And then reduce this by reducing the 2 over 2, which is 1. So my zeros are -1, 3 halves, and 4 plus or minus radical 17. So I input 4 plus or minus radical 17 on the calculator. So I did 4 minus radical 17, and I got -0.123, and it goes on forever, but I just rounded it to 3 decimal places. And I did the same thing with 4 plus radical 17, and that gave me 8.123. So if you look at the graph, it pretty much, that's what it tells us, right? 8.123 is the number, that's where it crosses over here. And then -0.123, I covered it up, let me just erase this here. -0.123 would be right here somewhere. So as you can see here, the Q is plus or minus 1, so my P over Q list is going to be basically the P. Plus or minus 1, plus or minus 2, plus or minus 4. And based on the graph, it looks like the 0 is 2, and not